Hi guys, this is Vineet, and in this video we will talk about the types of tables in SQL Server. Before we proceed ahead, I would request you guys to please go ahead and subscribe to my channel, as subscribing gives us huge motivation to create new videos for you and for other SQL professionals. Right now, if you see over the middle section of this slide, you will see that I have around 350 subscribers with 144 videos posted online. I would like this subscriber count to reach somewhere near 500 subscribers, so need your help and support here guys. So please go ahead and subscribe. There is a subscribe button below this video. Click on that subscribe button, you will get a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my upcoming videos. And also I post videos every other day, especially on Tuesdays, Thursdays and Saturdays. So if you subscribe to my channel, you will get timely notifications for those videos. Also on the right hand side middle section, you will see watch time from subscribers. So out of 100 viewers that are watching our videos, only 6% of them are subscribing to our channel. So I would request rest 94% of the viewers to please go ahead and subscribe to my channel. And on the bottom right corner, there is a section on how you can like my videos, subscribe to my channel, and enable the bell notifications. So you can use this video to perform these operations like subscribe and notify. Alright, let's move ahead, and there are some points to remember before watching this video. So please watch this video till the end to gain better clarity of the concept, and if possible for you, please watch this video twice. Perform any exercises in your lab or test environments only. Do not touch any production environment or production databases. We would like to know your thoughts regarding our videos, so please share your comments with us. In case you need the PDF copy of the notes that are discussed during the video, there are two methods to get the same. One is the free method, other one is the paid method. So first method is the paid method, where you can pay a nominal fee to get the notes. So in order to do that, you need to send me an email requesting for the notes and mention the video title for which you require the notes. So once I get your email, I will send you the payment link to make payment and download the associated PDF notes. Second method is free, which is basically you can subscribe to my channel. There's a subscribe button below this video. Click on that subscribe button. Once you hit on the subscribe button, it will show as subscribed, and you can take a screenshot of that section, including my channel name, the subscribe button and the video title, and send it to me over to my email address vermavane@gmail.com, highlighted in pink color here. So once I receive your email, I will check the video title and send you the PDF copy of the notes accordingly. I've curated some playlists for you to watch. These playlists contains around most of these playlists contains around 45 to 50 videos, including the database design playlist and the business continuity playlist. And basically the database design list contains videos related to database design, and the business continuity playlist contains videos related to disaster recovery and backup management. The third playlist is on SQL Server indexing. You can watch that out. The fourth playlist is on SQL Server performance tuning. And these the link to these four playlists, the links for these four playlists are mentioned there in the video description area, so please check those links out. And these playlists contains very useful videos for you to gain a better understanding in various domains of SQL Server. Apart from that, there's a fifth link, which is my channel page link, which is youtube.com/@SQL by Vineet. You can go to this link. This shows you my channel page, and from there you can subscribe to my channel, check out all my playlists, check out the latest videos, and it also curates the videos for you playlist so that it shows videos as per your interests. So please watch my channel page out. Now let's come back to today's topic, which is types of tables in SQL Server. So let me quickly go to notes. This will be a theoretical session, so there will be no practicals. Let me select my one pointer and begin. So alright, today's topic is type of tables in SQL Server. So we talked about the tables, which are basically user created tables or user defined tables. So apart from those tables, we have other types of tables in SQL Server. So besides the standard role of basic user defined tables, SQL Server provides the following type of tables that serve special purpose in a database. So apart from user-defined tables, we have other tables in SQL Server that are used for special purpose. Now first of them are partition tables. So what are partition tables? Partition tables are tables whose data is horizontally divided into units which may be spread across one or more file group. A big table can be partitioned into multiple tables, and these partitions can be stored in various file groups or across more than one file groups in a database. So what's the use of partitioning? Partitioning makes large tables or indexes more manageable, basically, by letting you access or manage subsets of data quickly and efficiently while maintaining the integrity of the overall collection. So partitioning is basically a process, or partitioning table is basically a process where we divide a table horizontally into multiple partitions, and each of these partitions are stored inside one or more file groups. Basically the advantage of partitioning the tables is that it makes the large tables or indexes more manageable in the sense that it lets us access or manage subsets of data quickly and efficiently while basically maintaining the overall integrity of the collection. And apart from the partition tables, there are temporary tables which we can create inside a database. Temporary tables are stored in the TempDB database, which is a system database. And there are two types of temporary tables. One is the local temporary tables and the global temporary tables, and they differ from each other in their names and their visibility and their availability as well. And local temporary tables basically starts with a single number sign, which is a hash, as the first character of their names, and they are visible only to the current connection for the user. So local variables are only available in the current session or current connection for the user, and they are deleted when the user disconnects from the instance of the SQL Server. So a local temporary table is only available to the user, a single user that is connected to the instance of a database, and once that instance is disconnected, we lose the local temporary table. In comparison, if we are using global temporary tables, which are defined with the double hash signs or double number signs as the first character of their names, they are basically visible to more than one user or to any user after they are created. So these are accessible to all the users, not just to a single user, but to all the users. And they are also deleted when all the users referencing the table disconnects from the instance of the SQL Server. So major difference between a local temporary table and a global temporary table is that a local temporary table is only available to a single user in a single instance of single session. For a single session, it is available to a single user, whereas the global temporary tables are available to many users in multiple sessions. So we will talk more about them in detail later on. When we will come across the global temporary tables and global local temporary tables. So far, we are giving here a short description. So they basically the temporary tables are not stored on disks. So they are stored in memory inside the TempDB database. And later on they get removed once the session is closed or once we disconnect from the instance of the SQL Server. And basically both the local and global temporary tables are basically differ in their visibility and basically in their naming conventions. So local temporary tables are available to only single user, whereas global temporary tables are available to multiple users in multiple sessions. Alright, let's talk about system tables. So apart from that temporary tables, we do have system tables as well in SQL Server. So SQL Server stores the data that defines the configuration of the server. So there is a data that defines the configuration of the server, and basically SQL Server stores that data in system tables, and it also stores data about all the tables in a database in a special set of tables known as system tables. Let me go through this statement again. So SQL Server stores the data that defines the configuration of the server. So server configuration data as well as data of all of its table in a special set of tables known as system tables. Users cannot directly query or update the system table. So users do not have any rights to directly query or update the system table. Instead, what is done? The information in system tables is made available through the system catalog views. So the system table information can be accessed through views, which are system views. We'll talk about them later in much detail. When we come across the system tables, we will talk more about that. Also, I have posted some videos related to system tables, so you can watch them out. I've given the description of each and individual system table elaboratively. So watch out my other videos. You'll find them online on my channel. Apart from these tables, the partition tables, temporary tables, and system tables, we have white tables as well. So what are white tables? So earlier in the previous video we have talked about that there is a restriction on the number of columns that can be present inside the user defined table. So that restriction is 1024 columns at max can be used inside the table. White tables basically extend this restriction. So white tables use basically the sparse columns to increase the total number of columns that a table can have to 30,000. So it basically white table increased that limitation of 1024 column limitation to 30,000 columns. It basically uses sparse columns. The white tables use sparse columns to increase that limitation of 1024 columns. Sparse columns are ordinarily columns. These are ordinary columns that have an optimized storage for null values. So basically white tables use sparse columns and these columns have an optimized storage for the null values. And sparse column reduce the space requirements for null values at the cost of more overhead to retrieve the non-null values. Although there is an advantage in using the sparse column that it provides us the storage availability by efficiently storing the null values, but this advantage comes at a cost of more overhead to retrieve the non-null values basically. So this is one of the disadvantage, that this advantage of storing the null values efficiently and providing us more space comes at a cost of overhead of retrieving the non-null values. A white table has defined a column set which is an untyped XML representation. So a white table basically consists of a series of columns, also known as column set, and this column has an untyped XML representation which basically combines all the sparse columns of a table into a structured output. And the number of indexes and statistics is also increased to 1000 and 30,000 respectively. So whenever we use white tables, the number of indexes in the table can be increased up to 1000 indexes, and statistics can be increased to 30,000 respectively. And the maximum size of a white table row is 8019 bytes. So due to this restriction, most of the data in any particular row should be null due to this 8019 byte restriction. The maximum number of non-sparse column, so here we are talking about the non-sparse column. So those columns plus computed columns cannot be more than 1024 columns. So apart from those 1024 non-sparse column and the computed columns, rest of them can be sparse column, and this limit can goes up to 30,000 columns. And white tables have the following performance implications as well. So we need to keep this in mind whenever we are using white tables. There are certain performance implications for using the white tables. Basically, white tables can increase the cost to maintain indexes on the table. First limitation is this: there's a cost increase to maintain indexes on the table, and the recommendation is that the number of indexes on a white table must be limited to the indexes that are required by the business logic. So whatever the most essential indexes that are required as per business logic are only should be kept on the tables. Any redundant or unusable indexes should be removed, because there is a cost to maintain the indexes on a white tables. As the number of indexes increases, so if we increase the number of indexes on the white table, so does the DML compile time. So DML is data manipulation language, and the compile time basically increases, and the memory requirement also increases if we use more number of indexes on a white table. If we are creating non-cluster indexes, those non-cluster indexes should be filter indexes that work on a subset of data. Okay, so non-cluster indexes should be filter indexes that are applied to the data subsets, and that is basically a recommendation. We don't want to put pressure or performance pressure on the white tables. If you need good performance, use the non-clustered indexes that should be filtered indexes in order to gain performance benefits. Now applications can dynamically add and remove columns from our white tables as well. So there can be applications which can dynamically add and remove columns from our white tables. So that basically is a schema change. Adding or removing a column from a table is a schema change. Now when the columns are added or removed, compiled query plans become invalidated. So compiled query plans are not valid anymore if the columns are added or removed. And the recommendation is that you design an application to match the projected workload so that schema changes are minimized. So it is recommended that schema changes should be minimized, and application should be designed keeping in this point in view and the projected workload, and basically there should be less schema changes so that we can gain performance benefits, or basically it should not hamper performance if we add and remove columns in a white table. Now when the data is added or removed from a white table, so we are talking about another point. Earlier we talked about adding and removing of columns. Now we are talking about the adding and removal of data from a white table. Performance can be affected. So whenever a data is added or removed from a white table, performance is affected, and applications must be designed keeping this point in view as well, and the projected workload, so that the changes to our table data is minimized. So white table should be made keeping in view that there should be less data modifications or insertions in that table, and basically application should be designed also keeping in view this point, and the projected workload and should be like that. There should be less changes in the table data. So application must be designed in such a way that modification to data is minimized. Limit the execution of DML statements on a white table that update multiple rows of a clustering key. So we should also limit the execution of any data manipulation statements on a white table that basically updates the multiple rows of a clustering key. And these statements can require, so the statement which are updating the multiple rows in a single attempt, this requires significant memory resource to compile and execute. So we should restrict the number of these DML statements that manipulate multiple rows in a clustering key of a white table. Now if we perform any switching operations on the partition, or switching partition operations on white table, these operations are slow and might require a large amount of memory to process, and the performance also hampers. The performance and memory requirements are proportional to the total number of columns in both the source and target partition. So if we are doing any kind of partition switching in white tables, this can be a slow operation, and it requires a large amount of memory to process, and what performance and memory requirements are needed is basically proportional to the total number of columns in the both source and destination partitions. Update cursors that update specific columns in a white table should list the columns explicitly. So if we are using any update cursors to update the specific columns in the white table, it should explicitly define the list for the for update clause, and basically this will help in optimizing the performance when you use cursors. Alright, so guys, we are done. In this video we have talked about various type of tables, including the partition tables, the temporary tables, and then we have talked about the system tables, and then we have talked about white tables, and we also talked about restrictions that are or performance implications that are applicable on the white tables. We have discussed 5 or 6 restrictions. So guys, please go through this video again in case you want to gain better clarity, and if you have any doubts, please do post your questions to us. We will try to answer them. I thank you so much for let me repeat, I thank you so much for your time on this video, and if you like this video, please click on the like button and do post us your comments. Please share this video with your friends and subscribe to our channel. There is a subscribe button below this video. Click on that subscribe button, it will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future videos. Please do share this video with your friends and also ask them to subscribe to my channel in case you feel my channel is useful for them. Thank you so much for your time on this video, and you have a wonderful day ahead.